All right, greetings everyone. Welcome to the first part of the video for section 4.4. We'll start looking at some properties of logarithms. So it turns out that when we have logs being added or subtracted, as long as they have the same base, there's some ways we can rewrite them. So we have both our sum of logs property as well as our difference of logs property. So the first one there, the sum of log property says that if we have the log of something plus the log of something else, again, assuming they have the same base, we can rewrite that as the log of the product of the two things. So as an example of that, if we had something like, say, log base 2, whoops, that's not anything. Let me try that again. If we have log base 2 of, say, x, plus log base 2 of 3. We can rewrite that as log base 2 of those two things being multiplied of the x and the 3. So of x times 3, which just becomes log base 2 of 3x. Okay, and as you can probably imagine, based on what you see what I did here, this is going to be useful for us to solve some equations that involve logs. The other thing about these properties is because there's equality here, it can also work the other way. So if we have a log of two things being multiplied, we can break that into log of the first plus log of the second. All right, and then the second one says that if we have the log of something minus the log of something else, we can write that as the log of the quotient of the two. So as an example of that, let's say we had log, actually, let's say we had ln of 4 minus ln of 2. Okay, so this works with natural logs too, because they're just log base e. Well, we can rewrite that as, based on what we see here, the ln of the first thing, 4, divided by the second thing. So actually, in this case, just becomes ln of 2. All right, which would be maybe a little easier to calculate or work with than ln of 4 minus ln of 2. All right, so let's take a look at how one way we could use these properties. So the first one says to rewrite the following as a combination of log functions. So that log of 5x squared over y to the 4th. So basically what we're going to do is expand this using those rules. So notice on the inside of the log there, we have two things being divided. So based on what we said on the previous slide, we could write this as log of the top thing, which is 5x squared, minus log of the bottom thing, which is y to the 4th. And then notice that inside of the first log, we have two things being multiplied, right? Now I know one's a number and one's a variable, but they're being multiplied. So based on those log rules, we can actually write those as two separate terms, or we could write that as log of 5 plus log of x squared. And then we still have the minus log of y to the 4th. Okay, and then I'm going to do one more step here. Bring this down here. And notice that log of x squared and log of y to the 4th both contain exponents. And we know by our exponent rule of logs, those can be moved out to the front. So this would become log of 5 plus 2 times log of x minus 4 times log of y. Okay, and so that's now been expanded out. So we started with log of 5x squared over y to the 4th. Now become log of 5 plus 2 times log of x minus 4 times log of y. Okay. All right, now on the second one there, we have 2 times log of x plus 3 times log of y. Now we're going to kind of do the opposite. So we want to work to condense this into a single log function. And the first thing I notice is there are numbers being multiplied out front. And as we just talked about, you know, when you have log of something to a power, you can bring the power down to the front. Well, just like with these other rules we've been working with, that can also work in reverse. So bringing numbers in front, or having numbers in front, we can actually move them inside and make them powers of those things. So this would become log of x squared plus log of y cubed. And now we have two logs being added. So based on our log properties, that can be rewritten as log of the first thing x squared times the second thing y cubed. Okay, so we end up with this. Any questions on that? Oh, I don't know why I just asked. There's no questions. This is a video. Silly Cody. All right, we'll leave it there for now. Thank you for watching.